This recording is to help you with lesson 9.02 on arithmetic sequences. Alright, arithmetic sequences are when you notice a pattern of whether you're adding a number to get the next number in your sequence or you're subtracting that number to get the next number in the sequence. So looking at this first one, we have to decide if it's an arithmetic sequence or not. So basically we're looking, are we adding the same number to get to the next term, or are we subtracting that same number to get to the next term? And for me, it helps to see everything written with a common denominator of 4. So that's what I did right here, is I took the sequence and I rewrote it with the common denominator of 4. And I look and I see, yeah, there's a pattern. It goes 9, 8, 7, 6, 5. So I'm subtracting 1 in the numerator each time. So I'm actually subtracting 1/4 each time to get the next number in the sequence. Because I'm subtracting 1/4 each time, it is an arithmetic sequence. And when it is an arithmetic sequence, that number that we're subtracting or adding is what we refer to as D. So if you see that, that's what D stands for. All right, next, it says write the first 5 terms of your arithmetic sequence. We know the first term is 3/2. And to find each resulting term then, we stick in the previous term and subtract off 1/4. So 3/2 minus 1/4 is the same thing as 5/4. Then we stick 5/4 and subtract off 1/4 to get 1. So 5/4 minus 1/4. And then we'll do 1, which is the same thing as 4/4, minus 1/4 to get 3/4. And lastly, 3/4 minus 1/4 is 2/4, which is 1/2. It does say to write the nth term of the sequence. The nth term can be determined by taking your first term plus n minus 1 times your difference. So here, a sub n equals 3/2 plus n minus 1 times negative 1/4, because we are subtracting off 1/4 each time. So when I distribute this and then combine like terms, let's see, I have 3/2 minus 1/4 n plus 1/4. So this is the same thing as 6/4. So 6 plus 1 is 7/4 minus 1/4 n. So that is the nth term of the sequence. That's what we can write that as. All right, next we're going to find a formula for a sub n for the arithmetic sequence here. So again, we need to know the first term. We have n minus 1, and we need to know the difference. We are given the first term, and we are given the difference here. So substituting those values in, we get 100 plus n minus 1 times negative 8. You can simplify this if you want. Otherwise, we can just leave it like this. Either one is fine. If I were to simplify it, let's see what we would get. We have a negative 8n plus 8. So really, if we were to simplify, we get 108 minus 8n. Either of those answers are acceptable. Okay, let's match the sequence with this graph. Because it's an arithmetic sequence, they are linear graphs because you're just adding on a number each time. In this case, it's kind of like writing it where your slope is 3/4. So if we were to write this as with y and x, it would almost appear as this. Okay, so it has a y-intercept of 2, and you can go up 3 and to the right 4 to find your next point each time and connect your points. So that should match up with your graph C because you have a y-intercept of 2 and a slope of 3/4. Right. Next, we're going to work on finding the nth partial sum of the arithmetic sequence. All right, because we are talking about sums, the nth partial sum can be found by doing n over 2 times a sub 1 plus a sub n. So we're going to need to know what n is, a sub 1, and a sub n. We're given this information right here. So I already know that n is 10. So I'm going to plug that in. A sub 1 is my first term, which is 40. And I need to figure out what a sub 10 is. So to figure out what a sub 10 is, we're going to have to create a formula for a sub n. So a sub n, remember, is a sub 1 plus n minus 1 times d. We're looking for the 10th term. I know my first term is 40. I know n is 10. And it looks to be that the difference is subtracting 3, so negative 3. So when I simplify all of this, I should get a positive 13 for a sub 10. So coming back to my formula, to find the sum, we have 5 times 53, and 5 times 53 is 265 for the sum. All right, next let's find the sum of the summation with n equaling 1 to 100. I know it's a little hard to read here. All right, so in order to find the sum, we need n over 2 times a sub 1 plus a sub n. So n, if we look, there are 100 terms, so n is 100. The very first term, well, if we plug 1 in for n, 5 times 1 is 5. If I plug 100 in for n, 5 times 100 is 500. So when we simplify, we get 50 times 505, which gives us an answer of 25,250. The last one we're going to go through, there's logs that are stacked in the pile over here. The top row has 15 logs and the bottom row has 21. How many logs are there in the stack altogether? So we are looking for the sum. So let's see what we all need here. How many rows are there? So n is the number of rows. Let's see, there are 1, 2, 3, 4, 5, 6, 7 rows. So that means n is 7. In the first row there are 15, and in the last row there are 21. So simplifying this, we get 3.5 times 36, which gives us a total of 126 logs.